Hello everyone. In this video, we'll be going over problem 15 of chapter 13 in the fundamentals of mass and heat transfer textbook. So this problem asks us to consider the arrangement of three black surfaces shown where A1 is small compared to A2 or A3, and asks us to determine the value of the view factor of A1 onto area 3, and to calculate the net radiation heat transfer from surface 1 to surface 3 if the area of 1 is 0.05 meters squared, T1 is equal to 1000 Kelvin, and T3 is equal to 500 Kelvin. So first thing, as always, in the work that I've already done, I've put down all the knowns and I recreated the sketch of the problem. I also decided that the surface surrounding A1 I would call A4, just to square everything off. So knowing view factor law, we know that f of 1 plus f of 1 2 plus f of 1 3 plus f of 1 4 is equal to 1. If you sum up all the surfaces, A1 looks at, if you look at all the surfaces, A1 will see everything that A1 sees. So right off the bat, because A1 is just a flat plane surface, we know that F11 is equal to 0. And also since area 4 it surrounds it is also a flat plane, F of 1 4 is also equal to 0. So that means that F of 1 2 and F of 1 3 added together is equal to 1. So now we got to determine F of 1 2 or F of 1 3. The problem asks us to find f of 1 3, but it will actually be easy to first find f of 1 2. If we go to the textbook and look at equation 13.8, it's already given us, it's already found what the relationship between two flat planes at a set distance are. And it tells us that f of 1 2 is equal to d squared over d squared plus 4l squared. D squared, of course, being the diameter of area 2, and L being the distance between the two surfaces. So if we plug that into the equation, we get a view factor from 1 to 2 of 0.36. Plug this into this equation up here, and we find that the view factor of surface 1 onto surface 3 is 0.64. So surface 3 is taking up most of the view of surface 1. So now in order to find the radiation, we just plug it into this heat equation. Q of ij is equal to A of I times the view factor of I to j times the Stephen-Boltzmann constant times the temperature difference between I and j. So of course, Q of 1 3 is equal to A1 times F1 3 times the Stephen-Boltzmann constant times T1 to the fourth minus T3 to the fourth. Here's all the values. And you plug all that together to get Q of 1 3 is equal to 1700 watts. Now, if you'll excuse me 1 second, I'm just gonna quickly verify the Stephen-Boltzmann constant for the sake of everything, which is going to be 5.67 times 10 to the negative 8. At this point, I just have this value saved into my calculator, and I can easily plug it in as a variable if the needs be. So that's how you approach this problem. I hope that this video was very helpful, and I hope that that the other videos on this channel will prove to be equally as helpful. Thank you for watching.